The year was 1951. America was obsessed with bigger, faster, and more powerful cars. Every major automaker was locked in a horsepower war. Ford was experimenting with new overhead valve designs. General Motors was pushing performance harder than ever. And Chrysler had a problem. Their brand new V8 engine was supposed to be a temporary solution, a stepping stone, something that would keep them competitive until an even better design arrived. But what almost nobody knows is that this temporary engine refused to die. For more than 2 decades, engineers tried to replace it. Executives planned its retirement multiple times. Entire programs were launched to make it obsolete, and every single time it fought back. Because the engine Chrysler tried to replace wasn't just another V8, it became one of the most successful engines in American automotive history. This is the story of the Chrysler Hemi's forgotten rival, the engine Chrysler never wanted to keep, the engine they simply couldn't replace, the Chrysler A-Engine. Most people hear the word Chrysler and immediately think of the legendary Hemi, the fire-breathing monster that dominated drag strips and racetracks. And for good reason. The Hemi earned its reputation through sheer performance, massive power numbers, racing victories, quarter-mile dominance. It became the stuff of legends, but while the Hemi grabbed headlines, another engine was quietly doing the hard work, the unglamorous work, the kind of work that keeps a corporation profitable. In the early 1950s, Chrysler engineers were developing a new family of overhead valve V8s. The company already had the famous firepower Hemi, introduced in 1951 with 331 cubic inches and around 180 horsepower. It was advanced, it was powerful. It represented the cutting edge of American engine design. The hemispherical combustion chambers provided exceptional airflow. Valves could be larger, compression ratios could be higher. Performance potential was extraordinary. Racing teams immediately recognized what they had. Street performance enthusiasts understood the significance. Engineers at competing manufacturers studied it carefully. It was also expensive, really expensive. The hemispherical combustion chambers required complex machining. Every cylinder head needed precision work that took time and money. The valve train was complicated. Dual rocker shafts, special push rods. Everything had to be manufactured to tighter tolerances. The cylinder heads were costly to manufacture. The entire engine was heavier and more complicated than many competitors. Production costs were substantially higher than conventional designs. For Chrysler's luxury cars and high-performance models, that was acceptable. But for volume production? For millions of mainstream vehicles? The math didn't work. Chrysler needed something simpler, something cheaper, something that could be installed across millions of cars without bankrupting the company. So engineers developed what became known as the A-Engine. Introduced in 1956, it looked almost ordinary compared to the Hemi. No exotic combustion chambers, no complex valve arrangements, no racing pedigree. Just a straightforward, conventional wedge-head V8. But appearances can be deceptive. The first version displaced 277 cubic inches using a 3.75-inch bore and a 3.125-inch stroke. Compression ratios varied depending on application, but most street versions sat between 8.01 and 9.01. Power output ranged from around 187 to 190 horsepower. Nothing revolutionary, nothing headline-grabbing. Compared to the mighty Hemi, it looked positively mundane. Automotive journalists barely noticed its introduction. Performance enthusiasts ignored it completely. Racing teams never gave it a second glance. But there was a reason engineers liked it. Actually, there were many reasons. The wedge-shaped combustion chambers were dramatically cheaper to manufacture than Hemi heads. A single rocker shaft per cylinder head, conventional push rods, standard machining processes. Everything simplified. The engine block was compact, the design was robust, and most importantly, it could be built in huge numbers. Manufacturing efficiency was extraordinary. Assembly line workers could install them quickly. Parts commonality reduced inventory costs. Bean counters loved it. Production managers loved it. And surprisingly, customers seemed satisfied with it. At first, Chrysler executives saw it as a practical alternative, not a legend, not a future icon, just a placeholder. something to fill the gap between economy engines and premium Hemis, a temporary measure until something better arrived. But then something unexpected happened. The engine kept proving itself. Year after year, model after model, vehicles equipped with the A-engine weren't the fastest. They weren't the quickest. They didn't win bragging contests at traffic lights. But they started every morning. They ran reliably. They survived neglect that killed other engines. Service departments noticed lower warranty claims. Fleet managers noticed reduced maintenance costs. And suddenly Chrysler had a problem they never anticipated. The replacement wasn't clearly better. By the late 1950s, displacement was growing rapidly. Customer expectations were changing. Bigger cars needed more power. Air conditioning was becoming common. Automatic transmissions were standard. All of that required more engine. So Chrysler expanded the A-engine family. The 301 arrived, then the 303, then the 313, then the 318. And that's where the story truly begins. Because the 318 cubic inch version became almost impossible to kill. Using a 3.9 1-inch bore and a 3.3 inch stroke, the engine struck a balance that engineers loved. The bore-to-stroke ratio was nearly square. That provided excellent torque characteristics across a broad RPM range. It produced strong low-end torque, it delivered respectable horsepower, and it survived abuse that destroyed other engines. The block proved exceptionally durable. Cylinder walls were thick enough to handle multiple rebuilds. Main bearing journals were generously sized. The bottom end was almost bulletproof. Fleet operators noticed. Taxi companies noticed. Police departments noticed. Owners noticed. While competitors struggled with durability issues, the Chrysler 318 developed a reputation for running seemingly forever. Taxi drivers would rack up hundreds of thousands of miles. Police departments would run their vehicles hard for years. Fleet managers would defer replacement schedules because the engines refused to quit. Stories began circulating. One New York taxi reportedly exceeded 400,000 miles on its original engine. A police department in the Midwest claimed their patrol cars routinely surpassed 200,000 miles. Fleet operators whispered about vehicles reaching mileages that seemed impossible. Were all the stories true? Probably not. But the fact that people believed them said everything. But there was a problem. The automotive world was changing, and horsepower was becoming king. By the early 1960s, the muscle car era was arriving. Customers wanted bigger engines, bigger numbers, bigger bragging rights. Performance was becoming the primary selling point for an entire generation of young buyers. Street racing was common. Drag strips were packed every weekend. Horsepower became currency. The humble A-engine suddenly looked outdated, or so everyone thought. Inside Chrysler engineering departments, work began on more powerful replacements. The company introduced the B-series big blocks, then the RB engines, massive displacement monsters like the 413 and the 426. These were serious performance engines. The 426 wedge made around 415 horsepower. The legendary 426 Hemi produced 425 horsepower officially. Unofficially? Much more. On paper, the future seemed obvious. The small A-engine's days were numbered. Why would anyone choose a modest small block when earth-shaking big blocks were available? Except reality didn't cooperate. The bigger engines made more power. Absolutely, but they also consumed more fuel, significantly more. They weighed significantly more, sometimes hundreds of pounds more, and they cost more to build, much more. The A-engine remained incredibly profitable. Every single unit sold generated healthy margins. Manufacturing costs stayed low. Warranty claims remained minimal. Even worse for Chrysler's replacement plans, customers kept buying it. Not everyone wanted a drag racing monster. Not everyone needed tire-shredding torque. Most buyers wanted reliable transportation, good fuel economy, low maintenance costs. The 318 delivered exactly that. Then came one of the most important upgrades in the engine's history. In 1967, Chrysler introduced the LA series, the Light A. Many people assume it was an entirely new engine. It wasn't. It was essentially an evolution of the original design. Engineers retained the successful architecture while reducing weight dramatically. The fundamental layout stayed the same. Bore spacing remained identical. Many components were interchangeable, but the execution improved substantially. The new block used thinner castings. Advanced metallurgy allowed thinner walls without sacrificing strength. The heads were redesigned. Combustion chambers were refined. Port shapes improved. Valve angles were optimized. The water jackets improved cooling. Heat distribution became more even. Hot spots were reduced. Reliability improved further, and weight dropped by nearly 50 pounds in some configurations. That might not sound dramatic, but in automotive engineering, every pound matters. Less weight meant better acceleration, better fuel economy, better handling, better everything. The most famous version, the 318 LA, suddenly Chrysler had an engine producing around 230 horsepower in certain applications while maintaining the legendary durability that made the original famous. It was lighter than before, more powerful than before, more efficient than before, and just as reliable. Engineers had pulled off something remarkable. They'd modernized a proven design without losing what made it special. And then the real surprise arrived, the 340. Introduced in 1968, the 340 cubic inch LA engine became one of the greatest small block V8s ever built. With a 4.04-inch bore and a 3.31-inch stroke, engineers created a high-performance masterpiece. The larger bore allowed bigger valves, airflow increased dramatically, breathing improved across the entire RPM range, compression ratio 10.51, horsepower officially 275. Unofficially, many experts believe it exceeded 300 horsepower from the factory. The cylinder heads flowed exceptionally well. Engineers had spent considerable time optimizing port shapes. Flow bench testing revealed impressive numbers. The camshaft was aggressive, valve lift was substantial, duration was long, the engine had personality. The forged crankshaft handled high RPM abuse. Unlike cast cranks in many engines, the 340 received forged steel. That meant strength. That meant durability under extreme conditions. And the engine loved to rev. At a time when many V8s ran out of breath above 5,000 revolutions per minute, the 340 happily pulled towards 6,000. The valve train remained stable. Power kept climbing. Drivers could use the entire tachometer. Road tests shocked journalists. A 1968 Plymouth Barracuda, equipped with a 340, could run the quarter mile in the mid-14-second range. Some magazine testers recorded even faster numbers. Car and Driver was impressed. Hot Rod praised it. Motor Trend called it one of the best small blocks available. And it wasn't just quick, it was balanced. Lighter than Chrysler's big blocks, more nimble, more efficient, and easier to live with. You could daily drive a 340. You could autocross it. You could drag race it. Versatility was extraordinary. But there was a problem. The golden age couldn't last forever. By the early 1970s, government regulations were changing everything. Emissions standards tightened. The Clean Air Act imposed new requirements. Catalytic converters were coming. Lead was being phased out of gasoline. Insurance rates skyrocketed. Young drivers with performance cars faced massive premiums. Some were essentially uninsurable. Fuel prices increased. The 1973 oil crisis changed consumer attitudes overnight. Suddenly, efficiency mattered more than performance. High-compression performance engines suddenly became liabilities. The mighty 340 was detuned. Compression dropped, camshaft profiles became milder, power decreased. Then discontinued after 1973, the 360 cubic inch engine replaced it. More displacement, less compression, different priorities. Many performance enthusiasts assumed this would finally end the A-engine story. The muscle car era was over. Performance was dead. Surely Chrysler would move on. They were wrong. Because while muscle cars were dying, durability still mattered. And durability was where the old Chrysler design excelled. The 318 continued marching forward, year after year, decade after decade. While flashier engines came and went, the 318 remained, constant, reliable, profitable. Mechanics began telling stories of engines reaching 200,000 miles, then 300,000. Some reportedly exceeded 400,000 miles with basic maintenance, oil changes, tune-ups. Nothing extraordinary, no exotic procedures, no special treatments, just regular maintenance that any owner could perform. One fleet manager reportedly joked that the body would rust away long before the engine quit. And honestly, that wasn't far from the truth. Rust Belt vehicles would develop structural problems while the engine ran perfectly. Bodies would deteriorate, frames would corrode. But the 318 kept running. The secret wasn't magic, it was engineering. Conservative engineering that prioritized longevity over peak performance. The crankshaft journals were generously sized. Larger bearing surfaces meant lower loads. Lower loads meant longer life. Oiling systems were reliable. The oil pump was robust. Oil passages were adequate. Lubrication reached everywhere that mattered. Cylinder walls were thick. Multiple rebuilds were possible. Some engines were rebuilt 3 or 4 times. Bearing loads remained reasonable. The engine never chased extreme performance at the expense of longevity. Instead, it focused on survival, and survive it did. By the late 1970s, Chrysler was facing serious financial trouble. The company desperately needed reliable products. Quality problems had damaged Chrysler's reputation. Recalls were common. Customer satisfaction was declining. The last thing they wanted was an expensive new engine program. Development costs were enormous. Tooling was expensive. Risk was substantial. So once again, the old design stayed. Not because executives loved it, because it worked, because it was paid for, because customers trusted it. As competitors introduced increasingly complex designs, the Chrysler small block kept doing its job. Millions were built, installed in Dodge pickups, Plymouth sedans, Chrysler luxury cars, police vehicles, commercial fleets, virtually everywhere. And then came another challenge. The 1980s, electronic controls, fuel economy regulations, computerized engine management. The automotive world was changing faster than ever. Carburetors were disappearing. Electronic fuel injection was arriving. Computer systems were managing ignition timing, air-fuel ratios, emissions controls. Many old V8 designs couldn't adapt. Their architectures were too primitive, their designs too outdated. But somehow the Chrysler small block evolved yet again. Throttle body injection arrived, a simple system that replaced the carburetor with electronic fuel delivery. Electronic ignition improved reliability. No more points, no more condensers. Timing became computer-controlled. Fuel economy increased. Efficiency improved significantly compared to carbureted versions. The basic architecture remained intact. Same block, same bore spacing, same fundamental design, but now wearing modern technology like a tailored suit. Imagine that for a moment. An engine whose roots stretched back to the Eisenhower era was now operating in the age of personal computers. When the A-Engine was introduced, computers filled entire rooms. Now they fit on engine blocks. Most designs don't survive 5 years. This one survived generations, and that's when Chrysler finally realized something. The replacement they'd been searching for all along wasn't necessary, because the engine they already had kept solving every problem. Need more efficiency? Update the fuel system. Need lower emissions? Revise the heads. Need better reliability? Improve the electronics. The foundation remained strong. The architecture remained sound. Everything else could adapt. The proof appeared everywhere. By the late 1980s and early 1990s, the 318 remained one of Chrysler's most trusted power plants. Production numbers climbed into the millions. Exact totals vary depending on variants and generations, but the combined A and LA family became one of the highest volume engine families Chrysler ever produced. Some estimates suggest well over 10 million units across all variants. That's extraordinary longevity. And yet, it rarely received the glory of the Hemi. It didn't dominate headlines. It didn't generate posters for teenage bedroom walls. It didn't become a racing celebrity. Instead, it became something arguably more impressive. Dependable. The kind of engine people forgot to appreciate because it simply kept working. No drama, no excuses, no surprises. Just transportation, day after day, year after year. Eventually, modernization became unavoidable. The automotive world moved toward entirely new engine architectures, overhead cam designs, advanced materials, computer-optimized combustion chambers. Magnum engines appeared. These were heavily revised versions with better flowing heads and improved efficiency. Then modern V8 programs followed. The Hemi name returned on entirely new engines. Advanced technology that would have seemed like science fiction in 1956. The original A-Engine family gradually faded from production. After decades of service, its long journey finally ended. The last examples rolled off assembly lines in the early 2000s, more than 4 decades of continuous production. But here's what's fascinating. Even after Chrysler officially moved on, enthusiasts didn't. Hot rodders still build 340S. The performance potential remains impressive. Modern parts improve reliability. The engines respond well to modifications. Collectors still hunt for high-performance versions. Original 340 engines command premium prices. Numbers-matching examples are prized. Truck owners still swear by their old 318S. Online forums are filled with high-mileage stories. Owners share maintenance tips. The community remains active. And countless examples remain on the road today. Drive through any American city and you'll see them. Old pickup trucks, vintage sedans, classic vans, still running, still working, still refusing to quit. Think about that. An engine introduced when black and white television was still common survived into the modern computer age. An engine designed before interstate highways existed powered vehicles on those highways for decades. An engine conceived when gas cost 20 cents per gallon, adapted to prices 20 times higher. How many mechanical designs can make that claim? Very few. And that's why this story matters. Most people assume automotive history is shaped by the loudest engines, the fastest engines, the engines that win championships. Sometimes that's true, but sometimes the most important engine is the one that quietly refuses to disappear. The Chrysler A-Engine never had the glamour of the Hemi. It never became a cultural icon. It never dominated drag strips or won NASCAR championships. Yet Chrysler spent decades trying to find something better. And somehow, every replacement ended up proving why the original was so good. Engineers would develop new designs, executives would approve production, marketing would promote the advantages, and then reality would arrive. The new engine wasn't significantly better, or it cost more, or it was less reliable, or customers simply didn't care. In the end, that's the real legacy of this remarkable V8. Not its horsepower, not its torque, not even its longevity. Its greatest achievement was forcing Chrysler to admit a simple truth. Sometimes you don't replace greatness, you simply keep building it. And that's exactly what they did for over 40 years, through countless challenges, through multiple generations of vehicles, through dramatic changes in technology, regulations, and customer expectations. The engine that was never supposed to last became the engine that refused to die. If you enjoyed this story, let me know in the comments which forgotten American engine you think deserves its own deep dive. And make sure to subscribe so you don't miss the next story from the golden age of horsepower, engineering, and automotive history.